example so that we can see exactly how this process works. Let's turn our textbooks to page 287. Look at the example we have there. Once again, you want to open the textbooks to page 287 and read the example that we have there. Page 287. The example reads as follows. A clothing manufacturer finds it profitable to make clothes for very tall and very short adult males. The executives decide to discontinue production of goods for the tallest 7.5% and the shortest 7.5% of the adult male population. Find the minimum and maximum heights they will continue to serve. The heights of adult males are normally distributed with a mean of 69.0 inches and a standard deviation of 2.8 inches. The figures are based on data from the National Health Survey, the United States Department of Health, Education, and Welfare, publication 79-1659. Now, the first thing you need to do here is draw a picture of the conditions. Now, they said that they were going to discontinue production of goods for the tallest 7.5% and the shortest 7.5%. So you need to draw a picture of that. You have a normally distributed population, and you're talking about the tallest 7.5 is to the right. So here you have your tallest 7.5%. The shortest 7.5% is to the left. So you have your shortest 7.5% on the left side. So your figure looks like that starting out. Now, your percents, you have to change into decimals. Your percent here is 7.5%. To change it into a decimal, you move your decimal point 2 places to the left. So I move a decimal point here 2 places to the left, and that gives me 0.075. And I add another 0 so that I have 4 significant digits like I have in the table in the back of the book. You change your percents into decimals. Once again, you have to change your percents into decimals. Draw a picture of what you have. Tallest 7.5% is way over here on the right. The shortest 7.5% is way back here on the left. So we change the percent into a decimal, move it 2 places to the left. It's right in between the 7 and the 5 now. We move it 2 places to the left. There's nothing in this place here, so we have to add a 0. So that's why we get 0.075. Then we add another 0 on the end so that we would have 1, 2, 3, 4. 4 significant digits. Now, we do the same thing on the other side. We have 7.5%. We change it into a decimal. It would be 0.0750. 0.0750. That's what it'll be. Now, they told us in the problem that the mean, the population mean, is 69.0 inches. 69.0 inches. Standard deviation is 2.8 inches. 2.8. So we know what the mean is, we know what the standard deviation is. Now, this is the mean. The mean is 69, or 69.0. That's the mean. Now, if we standardize this to get the z-scores, if we standardize this to get the z-scores, the mean would be 0. And over here we would have a z-score, and back here we would have a z-score. So we can have we would have 2 z-scores, z sub 1, z sub 2. Now you have the same amount of area on the right side of this z-score as you have on the left side of this z-score. You have 0.0750. That's how much area you have back here on the left side of this z-score. On the right side of this z-score, you have the same amount of area, 0.0750. So that means that those two z-scores are going to be the same, except that one will be positive, the one on the right will be positive, and the one on the left will be negative. That's what that means. So really, all we have to do is find the value of the z-score on the right. And then to get the z-score on the left, just make that z-score over there negative. Now that's what's in this problem. It doesn't happen in every problem. So you have to read the problem carefully to find out whether or not it happens in a particular problem. But it does in this problem. Now, so all we really have to do is find this z-score over here on the right. Now, if you look at table A-2, table A-2 will give you the z-score if the z-score, if and only if you know the probability between the mean and the z-score. You have to know this probability in here. In order to use that table, to find the z-score. And you need the score to find the raw score, to use the formula to find the raw score. So to find the z-score, you must know, to use table A-2 to find the z-score, you must know how much area there is between the mean and the z-score. That's what you have to know. And we don't know this at this point. But we do know that that half of this picture is equal to 0.5. Everything over on the right side there, it's equal to 0.5. And we can see that if we just look at what's on the right side there, that whole thing over there is 0.5. And we can see that if we take that much away, if we take the 0.0750 away, then we'll have just what we need to get the z-score. We have just what we need to use table A-2 to get the z-score. So what we have to do, we have to take that 1/2, which is 0.5, and we have to take away from that, or subtract from that, the 0.0750. Once again, that represents half of the area. The total area is 1. So half of it is 1/2, or 0.5. If we take that much away, we'll have the amount between the mean and the z-score. If we take that much away from the 0.5 we have there, we will have the amount, the area, the probability between the mean and the z-score. And that's what we need to use table A-2 to get the z-score. Now, to subtract this much from that half, to subtract this much from 0.5, we have to write it in this form. 0.5, we don't have any zeros in these places here, so we have to add on 3 zeros. Or you could do it on your calculator. If you do it on your calculator, you don't have to worry about adding in those zeros there. But if you do it by hand, if you have 0.5, which is half, you have to add the additional zeros there so that you can do the subtraction. So we do that, we do the subtraction, and we get 0.4250. 0.4250. So that's how much area we have in here between the mean and the z-score. We have 0.4250. That's what we have. And we got that just by subtracting the 0.075 from 0.5. Now that we have the area between the mean and the z-score, we can use table A-2 to get the z-score. So now we go to table A-2 on page 720. Let's open our textbooks to that. Open our textbooks to table A-2 on page 720, standard normal distribution. Now, when we open our textbook to that table, we are looking for this area, or this probability. The area of probability is 0.425. We're looking in the body of the table. That's where the probabilities are, or the areas are. They're in the body of the table. Over here you have your ones place and your tenths place for your z-score. Up here you have hundredth place for your z-score. But in the body of the table you have all your different probabilities. All your different probabilities. And you have the probability, all those probabilities, they represent the areas between the mean and the z-scores. That's what they represent. So you're looking in the body of the table for 0.4250. That's what you're looking in the body of the table for. 0.4250. So you're looking for that number. 0.4250. And you don't see it in the body of the table. But you see two numbers that it's between. This number here, 0.4250, is between two numbers that you see there in that table. It's between two numbers that you see there in the table. It's between 0.4236 and 0.4251. It's between 0.4236 and 0.4251. The exact number that you want is not in the table, but it's between two numbers that are in the table. Now, at this point, you have to decide which number is closer to. That's what you have to decide. You have to decide which number is closer to. Now, if you look at these two numbers, 0.4250, 0.421. You have only a difference here of 1. If you add 1, 0.0001, you'll get that. If you look at these two, you have more of a difference. You have more of a difference. So that means that the number that you're looking for is closer to this number here. 0.4250 is closer to 0.4251 than it is to 0.4236. And because of that, that's the number that you use to find your z-score. You use the number that your number is closer to. So we just can forget about the 0.4236 and also the 0.4250. And we use the number that the 0.4250 is closer to. And it's closer to the 0.4251. So that's the number that we're going to use to find the z-score. Now we're ready to find the score. We look at this number in the table, in the body of the table, 0.4251. We look straight over to the left. Let's go straight over to the left from that number all the way to the z column, and you'll see the first two digits of that z-score. You're looking at 0.4251. You're going all the way over to the left under z, and you should see 1.4. You should see 1.4. This is the ones digit and the tenths digit for the z-score. So we know the z-score is 1.4 something. The z-score here is 1.4 something. Now to find out what that something is, what the hundredths place is, you look at the 0.4251 again. again, and this time you go straight up to the top of the table. You go straight up to the top of the table there, and you'll see the hundredth place. You should see 0.04. You should see 0.04. So this tells us that the z-score here is 0.4. Once again, the z-score on the right side is 144. The z-score on the right side is 1.44. That's what the z-score on the right side is. Now, for the z-score on the left side, you have the same amount on the left side of the z-score on the left, but you had on the right side of the z-score on the right. So that means that this z-score here is the same as that z-score over there, 1.44, except it's negative. If a z-score is on the left side of the mean, it's negative. If a z-score is on the right side of the mean, it's positive. So this z-score here is 1.44. This z-score over here is a negative 1.44. And there is a raw score that corresponds to each one of those z-scores. And then we have to find them. We have to find out what the raw score is that corresponds to a z-score of 1.44 and what the raw score is that corresponds to a z-score of a negative 1.44. And to do that, we have to use the formula that we used before. We use the z-score formula. So let's take a look at the z-score formula and see how we use that to find the raw scores again. The z-score formula is z equals x minus mu over sigma. The z-score formula is z equals x minus mu over sigma. And we're going to do the positive z-score first. We'll do the 1.44 first. And then we'll come back and do the negative 1.44. You can do it either way. When you're doing your problems, if you want to do the negative one first, if you have a negative one, then you can do that. But we'll do the 1.44 first. So we're going to do this z-score, and we can call it z sub 2 if we want to, z sub 2, and we're looking for the raw score. X is what we're looking for, the raw score. So we substitute the thing we know into the formula. We know 2, that's 1.44. So we can substitute the 1.44 in the formula instead of z sub 2. So we can substitute the 1.44 in the formula instead of z sub 2. We know the value for mu, the mean. The problem said that the mean was 69.0. The mean is 69.0. We know the standard deviation. It was indicated in the problem that the standard deviation was 2.8. 2.8. So we can substitute those numbers. We can substitute those numbers into the formula. Now, we look at the problem. We want to solve it for x. That's what we want to do. Solve the problem for x. We look at the side of the equation that the x is on. We have x minus 69.0 divided by 2.8. So the x minus 69.0 is divided by the 2.8. So to get rid of the 2.8, we have to do the opposite operation. The opposite of divided by is multiplied by. So that means that we have to get rid of this 2.8, we have to multiply each side of the equation by 2.8. Once again, we want to solve for x. That means get x by itself. So the first thing we have to do is get rid of this 2.8. Everything over here on the right side is divided by 2.8. So to get rid of that 2.8, we have to multiply by 2.8. And remember, if we multiply the right side by 2.8, we have to multiply the left side by 2.8. You have to do the same thing to each side of the equation. Now, on the right side, the 2.8's cancel. On the left side, on our calculus, we multiply 2.8 times 1.44. We multiply 2.8 times 1.44. And we get 4.032. 4.032. On the right side, we now have x minus 69.0 because the 2.8's canceled. They cancel one another. Now, we're still trying to solve this equation for x. We're still trying to get x on one side of the equation by itself. Now, you should recall from your algebra class, your previous math classes, algebra and what have you, what you have to do now to each side of this equation to get x by itself. If you look at the right side of the equation, you see that if you can just get rid of that minus 69.0, you will have x by itself on that side of the equation. And thus you will have finished solving the equation. Now, you look at the x, you see that the 69.0 is subtracted from the x. The opposite of subtraction is addition. So to get rid of this minus 69.0, you have to add 69.0 to each side of the equation. You add it to the right side, you must add it to the left side. You add it to the right side, and you must add it to the left side. You have to do the same thing to each side of an equation. Now, this cancels. You get x by itself, which was your objective, to get x by itself, equals, on this side, you add these two numbers together. You get 73.032. 73.032. And that corresponds to the z-score on the right. That corresponds to the z-score on the right. So if we draw a little figure here of what we had originally, we would have the 69 in the middle, and on the right over here, we would have 73.032. 73.032. So that's the number there that would be separating that 7.5%. That's the height of the tallest person that this manufacturing company would be serving. Now, so we have found one of the raw scores that we needed to find. We need to find the minimum height. That's the maximum height there of the individuals that this company will serve. But we need to find the minimum height. And the minimum height would correspond to this negative 1.44 z-score. The minimum height would correspond to this z-score here, negative 1.44. We call it z sub 1. So to find that minimum score, we go back to the z-score formula. We go back to the z-score formula and we write it down. We write down the z-score formula. The z-score formula is z equals x minus mu over the z-score equals the raw score minus the mean divided by the standard deviation. and we substitute this z-score in the formula this time. We have already found z sub 2, the maximum height. Now we're looking for the minimum height, z sub 1. So this is z sub 1 here that we're talking about. And we know that z sub 1 is a negative 1.44. So that means that in this formula, instead of the z sub 1, we can substitute negative 1.44. Not positive 1.44, but negative 1.44. That's what we can substitute in that formula instead of z sub 1. Now, for the x is the raw score. That's what we're looking for. So we let that remain x. For the mu, the mean we said was 69 or 69.0. That's the mean, 69.0. The standard deviation again is 2.8. That's the standard deviation. So now we have to solve this equation for x to get the raw score for the minimum value. Once again, we look at the right side of the equation, where x is. We want to get x by itself. We look at the problem, we see that x minus 69.0 is divided by 2.8. We have to get rid of that 2.8. Since the x minus 69.0 is divided by 2.8, to get rid of that 2.8, we're going to have to multiply by 2.8. We have to do the opposite, or what we call the inverse operation. So we multiply the right side by 2.8, and we multiply the left side by 2.8. And I don't have enough room here over there on the left side. So what we'll do is move it down here. We have 2.8 on the left side times negative 1.44 equals x minus 69.0 over 2.8 times 2.8. Now, on the right side, we have divided by 2.8, we have multiplied by 2.8. What happens to the 2.8s? The 2.8s cancel one another. They cancel one another. Now, on the left side, we have a positive times a negative. Now, from your study of algebra, you should know that a positive times a negative will give you a negative. A positive times a negative will give you a negative. So on the calculator, all you really have to do here is 2.8 times 1.44. And that gives you 4.032. 4.032. Now, on the right side, as we said, the 2.8's canceled, so we end up with x minus 69.0. X minus 69.0. Now, we're looking at the right side again, because that's where x is. We're still trying to solve for x. We're trying to get x by itself. That's what we're trying to do. We look at the x, we see that the 69.0 is subtracted from the x. The opposite of subtracting is adding. So since the 69.0 is subtracted from the x, in order to get rid of it, we have to add it to each side of it. So we add 69.0 to each side of this equation. 69.0. We add that to each side of the equation. Now, on the left side of the equation, we have a negative number and we're adding it to a positive number. And you have to recall here from your previous study of mathematics, when you're adding two numbers together, if one is positive and the other one is negative, actually you have to subtract those two numbers. That's what you really have to do. You have to subtract the absolute values of those two numbers. So what I have to do here on a scratch paper, I have to take my 69.0 and I have to subtract my 4.032 from that. I have to do that on scratch paper or do it on my calculator. So I would take on my calculator, I would take 69 and then subtract from that 4.032. And that would give me 64.968. 64.968. And then, from your study of algebra, you should recall that you take the sign of the number with the larger absolute value. Absolute value, of course, essentially means looking at the two numbers without the signs and seeing which one is larger. And you can see that the 69 is larger than the 4.032. The 69 is positive, therefore the answer is positive. So the answer here is 64.968 equals, this cancels, we get x. That's the answer. X equals 64.968. X equals 64.968. So that represents the minimum, 64.968. And we can show that on this little figure that we have here. The mean is 69. So of course the minimum is on the left side of the mean. And that is 64.968. 64.968. So thus we have found the maximum and the minimum values. Now, the best thing to do at this point is to go back and read the problem. Make sure that you have answered the question that was asked in the problem, or that you have met the requirements of the problem. So we go back, we read over the problem, and we find out that we were asked to find the minimum and maximum heights they will continue to serve. So in our final analysis, we address what we were asked to do in the problem. And we indicate that the minimum and maximum heights will be 64.968 and 73.032 respectively. The minimum and maximum heights that they will continue to serve will be 64.968 and 3.032 respectively. Once again, for our final conclusion, we go back and read the problem, and we make sure that we have met the conditions of the problem. In this case, we were asked to find the minimum and maximum heights that this manufacturing company will continue to serve, or that the individuals in this manufacturing company will continue to serve. So we come back in the end and we address those requirements. And we state that the minimum and maximum heights that they will continue to serve will be 64.968 and 73.032 respectively. This means that the minimum is the 64.968. That's the first one. And the maximum is the 73.032. That's the last one. We could just have said that the minimum height that they will continue to serve is 64.968. The maximum height they will continue to serve is 73.032. So we could have stated our conclusion in that way. Now, just as a summary, let me review what we've done. We have discussed finding the raw score if you know the probability, or finding the raw scores if you know the probabilities. The first thing you will probably have to do in your assignment problems, you have to, of course, read the problem. After you read the problem, you should draw a picture of what the problem is indicating. Draw a picture of what the problem is indicating and indicating what you have to find in that picture. Show what you need to find in the picture. And then you're probably going to have to change your percents into decimals. The percents, they represent probabilities. But table A-2 does not give probabilities in the form of percents. So your percents, in order to use table A-2, you have to change your percents into probabilities and as a decimal, right? You have to change your percents into decimal probabilities. Now, once you do that, you have to make sure that you have 4 significant digits. In other words, you're going out to the nearest 10,000th place for your probabilities. Now, in some cases, you're going to have to subtract the probabilities that you're given from 0.5. So you have to read the problem carefully. In other cases, you won't have to subtract that probability. You have to read the problem. You have to use your brain to figure out whether or not you need to subtract the probability you're given from 0.5. If you draw a picture, that will help you to make that decision. Research has shown that if students draw pictures along with their work, they make better grades on their work, even if the pictures are not accurate. So the pictures don't have to be accurate as long as they show the relative positions of the different numbers that you have in the problem. Now, after you subtract your probability from 0.5 if you need to, then you have to look at the number that you get. And that's the number that you can look up in the table, because the numbers in the table, the probabilities in the table, they are probabilities of a number being between the mean and the z-score. That's what they represent. So in order for you to use that table, the probability that you use in that table, it has to be the probability that you have between your mean and your z-score. It cannot just be a probability way over in the right tail or way back in the left tail. It has to be a probability that's between the mean and the z-score in order for you to use that table to find the z-score. So once you get that probability, the probability that's between the mean and the z-score that you're looking for, you look in the body of the table for that probability. If you don't see that probability in the table, you write down the 2 numbers that it's between, and you pick the one that is closer to, and that's the one you use to find your z-score. If it's not closer to either one, if it's right in the middle of 2 numbers in the body of the table, then you use the smaller number. That's the way we'll be doing it in this class. We will not be interpolating. You could get the z-score of the smaller number and then attach a 5 to the right side of that number. But what we'll be doing, if you can't find the probability in the body of the table, if it's right in the middle between two other probabilities, then we'll be using the lower one. That way we'll all come up with the same answer to the problem. Now, after you find that probability, or the one that is closer to, or you use the lower one, you take that probability that you're going to use to get the z-score, whether it's the smaller one or whether it's the one that's the closer to or whatever, or what exact probability is in the table. You take that probability and you look directly to the left. Go directly to the left and look under the z column. And there you will see the ones in the 10th digit for your z-score. Then you go back over to that probability and go directly up. Go straight up and you'll see the 100th place digit. And that will be your z-score. That will be your z-score for that probability. Now, once you get the z-score, you go to the formula, and the formula is z equals x minus mu over sigma. Once you get the z-score from the table, you go to the z-score formula, and you substitute that z-score in the problem for z. You substitute the value for the mean in the formula for the mean. You substitute value for the standard deviation, and then you use what you know about algebra to solve that equation for x, which is the raw score. And that's what you'll be looking for, the raw score or the score in the problems that you'll be working with. So once you find x, once you finish using algebra to get x by itself, you'll have the raw score. So then, after you get the raw score, you go back and read the problem and make sure that you've met the requirements of the problem. And you make any conclusion that you need to make at that time.